in ADDR underscore any, so that's why we have used in underscore ADDR any right here. Okay, you can see here. So, and you can see that we have used the local host. Okay, so then we have the listen method. Okay, so basically what this method does, so basically it puts the server socket in a passive mode where it waits for the client to approach the server to make a connection. The backlog defines the maximum length to which the queue of pending connections for socket FD may grow. If a connection request arises when the queue is full, the client may receive an error with an indication of econ refused kind of error. So one thing that we have is the accept method. Okay, so here we have new socket equals the accept method. The first is so what this method does, that it extracts the first connection request on the queue of pending connections for the listening socket. Sock FD creates a new connected socket. So what this function does, that it extracts the first connection request on the queue of the pending connections for the listening socket, and it creates a new connected socket and returns a new file descriptor referring to that socket. At this point, connection is established between client and server, and they are ready to transfer data. Okay, so then we have the stages for the clients. Then we have the connect method here. Let us discuss that as well. So this connect method, what is it does, that it is a system calls that connects the socket referred to by the file descriptor, which is essentially server FD or socket FD, or here in our case it is sock underscore 1. It is also called as socket FD. So the server's address and port is specified in this address right here. Okay, we need to do this ADDR underscore length. Okay, so that is one mistake. Another error that we have, that is basically that this thing is SOCK ADDR underscore in. Okay, so mistakenly I basically wrote it the wrong way. So now we'd basically save it, and we'd come back here, we'd clear it, we run it again, and you can see that there are no errors here. Okay, so now we go back here, and now we write the client side here as well. So we write here -O, and we write here PC. Okay, we hit enter, and you can see that there are same kinds of errors here. So here we also in this client program we also need to keep it as SOCK ADDR underscore IN. Okay, so I save it. So now we run here the server program first. So we hit enter, and you can see that there are no errors in the server program. So now let's go ahead and let's run the client program. So we hit enter, and you can see here as well that there are no errors in the client program as well. Okay, so now we'd run the binary files as well. So first of all, we'd run the binary file of the server. So we hit enter, and so here you can see that now server is waiting for the client to connect. So now what we would do would basically run the binary file of client as well, and we hit enter, and you can see that it says hey message sent, and the client has sent the message to the server, and it says hey I am client, and then basically server sends the message, and here you can see that it says hey I am server. Okay, so that's it from the sockets. So now let's move on to the next topic. Okay, so the next topic is terminals and pseudo terminals. So first of all, we will discuss terminals and then we would come to pseudo terminals. So the idea is that on early Unix systems, terminals were real hardware devices connected to a computer via serial lines. Early terminals were not standardized, meaning that different escape sequences were required to program the terminals produced by different vendors. On modern workstations, such terminals have been superseded by bitmapped monitors running the X Window system. However, the ability to program terminals is still required when dealing with virtual devices such as virtual consoles and terminal emulators and real devices connected via serial lines. So terminal settings are maintained in a structure of type termios, which contains 4 bitmask fields that control various terminal settings and an array that defines the various special characters interpreted by the terminal driver. A range of functions perform various other terminal operations. These include changing the terminal line speed and performing line control operations, etc. So right now, with regards to terminal, we are just going to show you a simple command in terminal using which you can actually read the attributes of terminal, and then based on that you can do different things in coding as well. Okay, so so we won't do any code example around this topic. We'll just discuss what terminal and pseudo terminal is, and we'll just discuss a simple command. Okay, so now let's go ahead, let's go to our terminal, and in here we use the stty command, and then we write here -a, we hit enter. So now you can see that it has displayed to us all the terminal attributes. So the first line of the output that you see here, it shows the terminal line speed, bits per second. Okay, the terminal window size and the line discipline in numeric form, here you can say, which is 0. The next 3 lines show the settings of the various terminal special characters. The notation, this notation basically denotes control C and so on. Okay, so other you know, this one basically represents control U. Okay, this one control Q, you know, etc. Okay, so the string which is undef here, you can see here, this basically means that the corresponding terminal special character is not currently defined. So now let's discuss pseudo terminals. So the idea is that a pseudo terminal pair consists of a connected master device and a slave device. Okay, so together these two devices provide a bidirectional IPC channel. The benefit of pseudo terminal is that on the slave disk of the pair, we can connect a terminal oriented program that is driven by the program that has opened the master device. Okay, so the pseudo terminal slave behaves just like a conventional terminal. All of the operations that can be applied to a conventional terminal can be applied to the slave, and input transmitted from the master to the slave is interpreted in the same manner as keyboard input is interpreted on a conventional terminal. One common use of pseudo terminals is in application that provides network login services. However, pseudo terminals are also used in many other programs such as terminal emulators and the Script1 program. Different pseudo terminals APIs arose on System 5 and BSD. Linux supports both APIs, but the System 5 API forms the basis of the pseudo terminal API that is standardized in standard Unix system version 3. Okay. Okay, so the next topic is tracing system calls. So the idea is that in order to trace the system calls, we have the strace command that allows us to trace the system calls made by a program. This is useful for debugging or simply to find out what a program is doing. In its simplest form, we basically use this strace command like this. Okay, so let me just write it here. Let me just remove this, and you write this command like this, strace, all right, and then you basically have here the command, and then if you have the arguments, you're gonna have them here, and after that whatever you want to write. Okay, so basically this runs command with the given command line arguments, producing a trace of the system calls it make. Okay, by default strace writes its output to standard error, but we can change this using the -o file name option. Okay, -o is for the output. Okay, so by default it is gonna write the output inside the standard error file, but you can basically change it to any file you want. All right, so now let's go ahead and let's do some practical one or two example to see that how this strace works. Here is that even for a simple program, the output produced by strace is gonna be huge by the system calls executed by the C runtime startup code and the loading of the shared library. So it's gonna be huge. For a complex program, the strace output can be extremely long. Okay, so for these reasons, it is sometimes useful to selectively filter the output of strace and get the output that you just want. Okay, just get the piece of the output that you want. So first of all, let's try to use something. Let's try to use this command and let's trace something, and then let's try to filter it using grep. Okay, so we go to our terminal. Let me just clear it. So we go to our terminal, and here we write here strace and then date. So we trace all the setups and functions related to date. We hit enter, and you can see that here we have a lot of output. Okay, so let's say that I just want to filter this open. Okay, so for that what I would do, I would basically rewrite the command, but let me just clear it first so that you can see it clearly. So I would just rewrite that command, and just after that I would have a pipe sign, and then I will write here grep, and then I would write here open, let's say. Okay, so now if I hit enter, you can see that it has filtered out only the open sort of output. Okay, so this is just a piece of the huge complex output. All right, so another method is to use the -e or -e option to select the events. For example, if you want to trace open and close system calls, so in that case, system calls or functions, in that case what you're going to do, that you are going to write here strace, and then you're going to write here -e. Okay, that is the flag that you're going to use. Then you write here trace equals open comma close, and let's write here date. So if you hit enter, now you can see that it has traced all the traces regarding open and close, in which we don't have any open system call right now, so we had only close calls, so it has just basically traced all of them. Okay, so here you can see. So that's it from this topic. So now let's move on to the next. Okay, so the call to action to buy the book from the link below. Okay, so what I have done, that I have put the link in the description where you can go, and it would be something like this, and from here you can actually buy this amazing book. So I hope you have enjoyed this entire course. There's a lot of work that we have put in creating it. So if you have any kind of questions, ask us in the comments below. You can subscribe to our channel and make sure that you buy this book and you read it and you see for yourself that how valuable this book is. And you know, the thing that we have done, we have created this course, but we have just scratched the surface. Okay, so in order to fully understand all the concepts, make sure you buy this book and you read it, and I will see you in the next video.